Right now, a massive, invisible engine in the Pacific Ocean is failing. For tens of thousands of years, this engine has reliably dictated who gets rain, who gets drought, and what the global temperature will be. But the current cycle is doing things it absolutely shouldn't. California was supposed to be bone dry this season. Instead, it got slammed by catastrophic rainfall. Australia was supposed to be cool and wet. Instead, it baked under unusual heat. We rely on this ocean system to act as the Earth's natural air conditioner, but the thermostat is fundamentally broken. And what scientists are seeing in the data for late 2026 and 2027 is genuinely alarming. The rules of global weather have just been rewritten, and we are completely unprepared for the extreme whiplash that is coming next. To understand the immense severity of this threat, you have to understand the heartbeat of our planet's climate, a phenomenon known as the Niño-Southern Oscillation, or ENSO, operating across the Pacific Ocean, a body of water so unimaginably huge that it covers more area than all the land masses on Earth combined. This oceanic leviathan acts like a giant planetary seesaw. Every 2 to 7 years, it tips the entire world between two opposing climate extremes. On one side of the spectrum, you have El Nino, the aggressive warming phase. On the other, you have La Niña, the global cooling phase. When La Niña takes the reins, it usually means that exceptionally strong trade winds begin to howl across the equator, pushing massive volumes of warm surface water westward toward the coasts of Asia. This intense displacement forces a dramatic reaction on the opposite side of the Pacific. It drags deep, freezing ocean water up from the abyss to the surface along the western coast of South America. It alters the path of the global jet streams. It alters the path of the global jet streams. It shifts the trajectory of deadly hurricanes. It historically dictates the success or catastrophic failure of global agriculture. For centuries, a standard La Niña year guaranteed heavy, reliable monsoon rains for Australia, Indonesia, and Southeast Asia, while simultaneously starving the American Southwest of moisture, triggering predictable dry spells in places like Southern California. It has always been a reliable global tug of war, or at least it used to be. Enter the 2025 to 2026 La Niña. By every historical metric, this cycle is an imposter. It formed incredibly late in the year, entirely missing the crucial seasonal windows where it normally asserts its dominance over the Earth's atmosphere. It is remarkably weak. Barely registering the ocean temperature drops required to even be officially classified as a La Niña. And now, it is completely falling apart much faster than anyone anticipated. Because it lacks the raw thermodynamic strength to steer the global climate, rogue weather systems have violently taken the wheel, exploiting the power vacuum. This weakness is exactly why global weather forecasts completely disintegrated this year. Look closely at what just happened in California. So during a standard La Niña, the jet stream shifts northward, effectively pushing winter storm tracks up into Canada and the Pacific Northwest, leaving California parched and bracing for drought. But instead, California faced a relentless, destructive barrage of water. This happened because of a phenomenon known as atmospheric rivers. These are colossal, invisible rivers of dense tropical moisture floating miles above our heads. A single strong atmospheric river can carry up to 15 times the volume of water flowing through the mouth of the Mississippi River. Crucially, atmospheric rivers are wild cards. They are not strictly controlled by the ENSO cycle, because this current La Niña was far too weak to establish its usual atmospheric high-pressure shield. These rivers crashed directly into the North American West Coast unimpeded. They funneled deep tropical moisture from near Hawaii and dumped half a year's worth of rain onto California in a matter of weeks, triggering deadly landslides and overwhelming reservoirs. On the exact opposite side of the globe, Australia was experiencing the devastating flip side of this failure. Australia traditionally relies heavily on La Niña for drought-busting summer rains and cooler days. Instead, the continent was left sweltering under unusual, unseasonable heat, dominated by separate localized Indian Ocean weather drivers that easily crushed the pathetic La Niña signal. The Earth's natural air conditioner was technically turned on, but absolutely nobody felt the breeze. So what exactly is paralyzing La Niña? Why is this ancient climate rhythm suddenly missing a beat? The answer lies in the rapidly rising baseline temperature of our planet. The Earth is simply becoming too violently hot for La Niña to do its job. Imagine trying to cool down a massive warehouse with a cheap desk fan while a heavy industrial furnace is blasting at maximum capacity in the corner. That furnace is human-driven climate change. The world's oceans are the Earth's primary heat sink, absorbing over 90% of the excess heat trapped by greenhouse gases over the last century. Because of this accumulated energy, even when La Niña successfully tries to pull cold water up from the deep to cool the surface, the surrounding oceans and the atmosphere are so intensely hot that the cooling effect is instantly neutralized. Even during our most recent triple dip, La Niña years earlier this decade, which historically should have provided a noticeable multi-year dip in global temperatures, the planet just kept breaking all-time heat records regardless. The background warming is entirely overwhelming the natural cycle. Furthermore, this trapped heat fundamentally changes the physics of our atmosphere. According to the laws of thermodynamics, a warmer atmosphere acts like a giant, invisible sponge. For every 1 degree Celsius the air warms, it holds about 7% more water vapor. This creates a terrifying, compounding paradox for global weather. It means that dry areas evaporate faster, relentlessly sapping moisture from the soil and leading to sudden flash droughts and explosive, fast-moving wildfire conditions. But when that boiling air finally encounters a storm system, it doesn't just rain, it floods. It unleashes a localized deluge. The natural dice aren't just loaded anymore. We are playing a completely different game on a completely different board, where the extremes are violently magnified. But the most concerning part of this failing La Niña isn't what's happening right now. It's the catastrophic setup for what comes next. Ocean models and climate scientists are currently watching a massive, deeply concerning pool of warm water building rapidly beneath the surface of the Pacific. This incredibly brief, weak La Niña is already collapsing, actively being torn apart by shifting westerly winds. And the data points to a violent swing in the absolute opposite direction. A potential supercharged El Nino developing by late 2026. This terrifying phenomenon is known as climate whiplash. We are moving from a suppressed, a failed cooling phase directly into an amplified warming phase at breakneck speed. Historically, rapid turnarounds like this are deeply jolting to global ecosystems. It means that within a tight 12-month window, entire regions might go from one devastating extreme directly to the other. Topsoil that was completely washed away by unprecedented floods in California could be baked into cracked concrete by a severe El Nino drought next year. Regions in Australia, Africa, or South America that barely survived the recent heat could face massive, synchronized agricultural collapse. And the global temperature stakes have never been higher. If El Nino arrives on schedule late this year or early next, it will stack its own intense, natural ocean heating effect directly on top of our already record-breaking global baseline. Forecasts from major meteorological organizations are already warning that this exact combination could push global temperatures in 2027 to heights humanity has never experienced in recorded history. We are staring down the barrel of synchronized global extremes where multiple breadbasket regions, the vital areas that grow the vast majority of the world's food, could be hit by simultaneous droughts and floods, drastically disrupting global food supplies, crashing economies, and triggering supply chain nightmares. We are officially entering an era of unprecedented volatility. The safety nets of historical weather patterns are gone. ENSO is no longer the sole reliable driver of our weather. It is violently competing with a turbocharged, chaotic climate system. But we are not flying blind into this storm. Our ability to monitor these massive planetary shifts is the best it has ever been in human history. Fleets of highly advanced satellites are orbiting right now, measuring sea surface heights down to the millimeter to track ocean temperatures and atmospheric water vapor in real time. Supercomputers are crunching this data, giving us months of vital warning before these massive climate flips fully materialize. We know exactly what the ocean is doing, and we know exactly what is coming. The monumental challenge now is adapting. Our infrastructure, our global agriculture, and our emergency response networks can no longer rely on the comfortable weather data of the past century. We have to engineer our societies for the extremes. We have to build cities that can handle sudden deluges and farming systems that can survive flash droughts. We must prepare for the whiplash. The old baseline is dead, and the new normal is pure unpredictability. The global climate is changing faster than ever, but so is our understanding of it. If you want to stay ahead of the curve and understand the massive, invisible forces shaping the future of our planet, make sure to hit that subscribe button right now. Leave a comment below letting me know what bizarre or extreme weather you've noticed in your own area recently, and I will see you in the next video.